to get that $15,000 in 8 years. All right, so the next thing that I want to look at is this number called E. And what we're looking at is they give us a hypothetical question. It says, suppose a dollar is invested at 100% interest per year. And let's compound it n times per year. And the interest rate, because we're writing it as a decimal, when you write 100% as a decimal, that's 1. So the interest rate per period then is going to be 1 over n. So we're just simply here using our little formula that we already had. And according to the formula, since our initial amount is 1, then the compound amount, what I'm going to earn by the end, is going to be this value right here. All right, so what we're being asked to do is we're asked to take the number of times we compound per year and start raising that. Like right now, we're only used to doing that annually or semi-annually or monthly or daily or quarterly. This is saying, hey, yeah, go ahead, compound it 1 time in the year, that's annually, or compound it twice in the year, that's going to be semi-annually. This one we're not familiar with, we don't have a word for it, but compound it 5 times a year until we get to the point where it says, no, compound it 1,000,000 times per year. So let's look at what would happen then if I keep increasing the number of times that I compound my interest. So if I compound it semi-annually, we're going to get 2.25 or $2.25. And if I compound it 5 times a year, I'm going to start keeping a lot of decimals. You'll see why in a moment. So I'm not just keeping the number of decimals for money here. If I compound it 5 times per year, I'm going to get this decimal 2.48832. Well, then let's compound it 10 times per year. And you'll notice that each time my money amount is going up a bit. Well, then if I unhide all the rest, you can pause the video and go ahead and take your calculator out and figure out the next 4. I'm just going to unhide them all at the same time. And what you're going to notice is that each one, yes, it keeps raising, but the more times I compound per year, the less it raises. In fact, it looks like it's starting to get close to this magical number of 2.718 something. And what we end up finding out is that as n keeps getting compounded more and more and more times per year, my function is getting closer to a fixed number. My fixed number has a name. It's called E. In fact, if you'll look at your calculator, I don't think I have, oh, good, here's my calculator. If you'll look at your calculator on the left column, and you don't need to worry about what's there in my screen, but on the left column, notice that there's an LN button. Right up above the LN button is this little symbol that says E raised to the X power. So let's do this. Let's look at E raised to the first power. This is going to give us the value of E. And you'll see there's our magical number, 2.718. 2818285, and it's going to keep on going forever and ever and ever. It's a lot like pi in that it has an infinite number of decimal places. So let's go back to our notes then, and you see that the value of E is this number that I can find in my calculator. E, please note, E is a number. It is not a variable. It is not a letter that can change as much as I want it to change. Well, one way that I can use E is for continuously compounding. So this is for compounding more often than annually or semi-annually or quarterly, monthly, or daily. This is for compounding every moment of every day. And what you see here is I still have P dollars. This is still my initial amount. I still have my interest rate that we're still going to write as a decimal. I still have my time measured in years. And I still have my future amount that is called A. The only thing that's different here is that I have this number, this 2.718 yada, yada, yada number that's in my formula. For the record, I do call this the shampoo formula. For those of you who are listening and you are over the age of 40, you'll know what Pert shampoo is. For the rest of you, go look it up. They still sell it. But I call this one the shampoo formula, or sometimes I'll call it the clean formula. I'll go back to this one. Sorry, it's all the way back here. And this one I call the dirty formula simply because it's messier. It has more stuff in it. So the clean formula and the dirty formula. And so look at example 9. We're depositing $8,000. Our account is going to be paying 5% interest, and we're going to compound continuously. So we're good. This is what tells us to use our shampoo formula or our clean formula. And we're going to do this for 6 years. So we want to find the future amount or the total amount that we have at the end of 6 years. So I've written down my formula. Let's go and substitute the values that we need to. So 8,000 is our starting amount. E is our number. And so we're going to use our calculator here in just a moment. R is 0.05. Don't forget to write it as a decimal. And then times our time. So use your calculator then, and you're going to use that E button. You're going to raise that E button to the 0.05 times 6 power. I'll do this first one for you. I'm not going to always show you this, but so we have $8,000. Whoops, let's get rid of that. $8,000. And we're going to multiply that by E raised to the 0.05 times 6 power. And then you can see there that we have the value of $10,000, $10,798.87. And so if I uncover what I have here, that's exactly what I've got, $10,798.87. Now, back in example 7, so I'd like for you to pause the video and let's go back really quickly and look at example number 7. We found that the total amount of deposit after 10 years in our account, we paid 3% semi-annually, was $2,500 that we were investing. We're asked to not just look at this semi-annual investment, the semi-annual compounding, we're asked to look at the other types of compounding as well. So let's go compare. What does it look like if we compound it annually, or quarterly, or monthly, or daily, or even continuously? So the first 5 of these, we're going to use that messy formula, the dirty formula. Now, you can just go back to example 7 and copy the semi-annually. We've already done that work, so let's not take any extra time to do that. So that's going to be $3,367.14. That's what we found back then. Notice that I didn't even write down a value for annually, and I'm being lazy here. It didn't ask me for annually. It only asked me for quarterly, monthly, daily, and continuously. But you can find that if you want. I did not even write it down in my paper notes to be able to hand that to you. All right, if we invest quarterly, that's going to be $3,370.87. Monthly will be $3,373.38. Oh, we gained a whopping $2 and something. If we compound daily, this is going to be $3,374.61. And then if we compound continuously, so this is the one where we need to change our formula. So we compound continuously, we're going to get $3,374.65. So you'll notice that each time I get a little bit more. It's not crazy significant, but it is a little bit more. All right, for the last example of this section then, let's look at a non-money question. So we are told that the exponential growth of the deer population in the country can be calculated by using the following model. And so here's the model that they gave us. And now they're going to explain what each piece is of the model. So 20,000 is the initial deer population. 0.08 is the rate of growth. T is going to be the total population. And N is going to be the number of years that have passed. So for part A, we're asked to predict the total population after 4 years. So we're going to keep our equation exactly the same. The only thing that we're going to change is our power. And so 4 years have passed. So we go and we plug that into the calculator, and we get 27,209. But please note, we were supposed to round to the nearest thousand. So we're not going to, and by the way, you cannot have part of a deer. So, if your calculator said that you had 27,209 and 0.78, it's kind of going to get messy if you have 78 hundredths of a deer. So be careful about that. You cannot have a part of a deer without it getting messy. But this was asking us to round to the nearest thousand. So this is going to be 27,000 deer approximately in 4 years. Now, part B asks us a different question. It says if the initial population is different, let's say it's 10,000, and now the growth rate is 15% or 0.15, approximately how many deer are going to be present after 2 years? So again, we'll use the same formula, except that we're going to just change some of the numbers in our formula. So the initial amount is going to be that 10,000. My rate of growth is going to be 15%. And the number of years now is going to be 2 years. So we'll throw that into the calculator. And once again, we were asked to round to the nearest thousand. So the answer that we would enter into our system is going to be 13,000 deer approximately. All right, that takes care then of all of the videos that we have for section 4.2.